So let's talk about the mole, section 4 of your blue note packet. Now maybe you're thinking about the animal mole. That is not the kind of mole we're talking about in science. Here's what you gotta know. The mole is a unit of measure. Just like a dozen is a unit of measure of 12, and a pair is a unit of measure of 2, a mole is defined as 6.02 times 10 to the 23 particles. It's a number of particles. So for example, 1 mole of copper is equivalent to 6.02 times 10 to the 23 copper atoms. And 1 mole of water, which we know is H2O, is 6.02 times 10 to the 23 water molecules. The gram formula mass is the mass of grams. This is the exact same thing we use, the mass of grams of 1 mole, or this many particles of a substance. So let's do a little conversion. I know that 1 atom of iron, or Fe, has 55.8 AMU based on my reference table, but 1 mole of iron will have this many iron atoms in 55.8 grams. If I had a formula mass of carbon dioxide, which would have 44 AMU, using again your reference table, while the gram formula mass of carbon is 44.0 grams per mole. Instead of using AMU, we're talking about the number of grams in every 1 mole, or in every 6.02 times 10 to the 23 atoms. So what's that look like if we were going to do a conversion? Well, first of all, you can find the equation I'm going to use for the conversions on, guess what? Table T under mole conversions. I'm just going to write down the formula at the top so you can see. The formula you find on table T is the number of moles is going to be equal to the given mass, that's going to be in grams, over the gram formula mass, which you can find right from your periodic table, and we've been doing the previous part of this unit. So let's try an example together. You've got the mass in 2.5 moles of sodium. That's what I want to know. What is the mass in 2.5 moles of sodium? The first thing I can do is, looking at this equation, I know the number of moles of sodium that I have is 2.5 moles. I also am going to be able to figure out the gram formula mass using my reference table. Now I know that sodium is Na. So if I find Na on my reference table, I'm going to be able to see that there are 22.99 grams in 1 mole of sodium. So now we can do our little conversion. Let's plug into our formula up here. We have the number of moles is 2.5. We are looking for the given mass. I'm just going to leave that as M. That's what we're trying to find. And over the gram formula mass is 22.99 grams in every mole of sodium. Now, you can do a little bit of cross multiplication here if you'd like. Multiply both sides by 22.99. You get 2.5 moles times 22.99 grams. That's going to be equal to the mass. That's what we're looking for. If you put that in your calculator, do a little bit of math, you're going to get 57 grams of sodium is equal to the mass. That's the amount that we have in 5 moles, or sorry, 2.5 moles of sodium. Let's try another. Same question. What is the mass in grams, 0.5 mole of NH3? Now this is interesting. When we got to find the gram formula mass, we're going to need to split this into elements. So let's go back to what we did before. The gram formula mass, I'm going to write down first every element, N and H, and then how many of each I have. I've got 1 nitrogen and I've got 3 hydrogens. I go to my reference table, I see that nitrogen has 14.01 grams, and I see that hydrogen is 1.01. So when I do a little bit of math, I end up with 3.01 for hydrogen and 14.01 for nitrogen. I add those two together to get my gram formula mass, and I end up with a grand total of 17.01 grams total. So what I do with that is my gram formula mass for this molecule. That's the total. I also know the number of moles. I've circled that. So let's put this into our equation. We know that we have 0.50 moles. We're looking for the mass again. And I know the gram formula mass is 17.01 grams. Do your math again. Multiply both sides by 17.01 grams. 17.01 grams. And you end up with a grand total of 8.5 grams of NH3, and that is the mass that I have. All right, we've got another, but this time we're looking for how many moles there are in 66.0 grams of CO2. Okay, so if I start looking for this formula, I'm looking for the number of moles. I'm still using that same equation from table T. I'm looking for the number of moles. This time I'm given the mass. I know that I have 66.0 grams of CO2. But the question is, what's my gram formula mass for CO2? Well, do the same thing. In order to find the gram formula mass, we need to find first the mass of each element using our periodic table. Carbon, I have 1. Oxygen, I have 2. Let's do a little bit of math here. Oxygen is 16.00 from your reference table, and carbon is 12.01. Multiply those, and I'm going to add to get a gram formula mass total of carbon dioxide. When I add those together, I get 44.01 grams. That's great news. Now I know my gram formula mass. I can write it in here. 1 grams. Divide 66 by 44.01, and you end up with the number of moles of CO2, which is what we're solving for, as being 1.50 when you round moles. That is a lot of molecules. Let's try another. Again, how many moles are in 49.0 grams of, we got a lot of elements going on. So the first thing I want to do is set up my formula. I'm looking for the number of moles. I'm given the mass of 49.0 grams. That's how much of the sample I have. But what I want to know is the gram formula mass. How much, what mass of each sample is in 1 mole. So here I'm using my reference table again. I've split up each of the 3 elements I have. I know I have 2 hydrogens, 1 sulfur, and 4 oxygens. Use your reference table. You'll find that there are 1.01 grams in each hydrogen, for a total of 2.02 grams. You'll find that for sulfur, there's a total of 32.07 grams in 1 sulfur atom, so we'll end up with 32.07, and there's 16.00 grams in each oxygen, to give us a grand total of 64.00 grams for the oxygen. Add them up to get our gram formula mass, and you're going to end up with a grand total of 98.09 grams. There's a gram formula mass. I pop it in here, 98.09 grams. Divide the top by the bottom. You end up with the number of moles H2SO4 as being 0.5 moles for a grand total. Okay, we've got one more problem. How many grams I'm looking for are in 3.5 moles of chlorine? Well, here, this is a little different because they give us the name of the element, chlorine, but they don't give us the formula. So I made a little note at the bottom. We have to remember this. It's coming back to our diatomic elements. Which elements are diatomic? Remember real quick, when they're not combined with other elements. This is our classic Clarence-Hofbrinkel equation. So notice, you see, chlorine is a diatomic element, which means when I write the formula for chlorine, it's Cl, but it always comes with another chlorine. It always comes with a buddy. So when we solve for this, it's going to matter that we have 2 chlorines. So let's set it up again. I have my number of moles this time. It's 3.50 moles. I want to know the grams, the amount of mass, is what I'm looking for, in this many moles of chlorine. So I go over to the side again, I got to calculate the gram formula mass. The only element I have is chlorine, but got two of them. So you go to your periodic table, you'll see that chlorine in each atom has a mass of 35.45 grams. Multiply that by 2, you get 70.9 grams. That is your gram formula mass for a diatomic chlorine atom. Pop that over here, 70.9 grams. And you end up with a grand total mass of 22.7 grams of chlorine as your final answer. Now remember, star it. We do care about our diatomic elements when we're solving for the gram formula mass. Having 2 chlorines is going to change my answer. That's all for today. What you're going to want to do is watch the video on a mole. That number is huge, and it's really hard to picture. So this TED Talk's best example I can have of how to picture a mole. Enjoy class, have a great day, and I'll see you guys Monday.